for the case of distillation, we just going to use binary mixture, which means that we have component A and component B. Okay, so we are not dealing with multi-component mixture. Okay, so for distillation, just remember that we only deal with two components, A and B. All right. Okay, so you're going to apply Roth's law. Okay, this one I have explained to you, and Dalton's law. All right. So for Dalton's law, we are dealing with the vapor. Okay, so that when you want to find the partial pressure of A in vapor phase, you can also use the mole fraction of vapor, the mole fraction of A, okay, in vapor phase, in vapor phase, multiply with the total pressure. Okay, so you can use this one. All right, you can use this one. So please check this one. I think this is this should be a vapor phase. Okay, so you can correct this one. All right. So you can also use a few other related equations come from Roth's law and Dalton's law. Okay. So if you were to use the combination of Roth's law and Dalton's law, all right, you can come up with the equation number 1 and equation number 2. Okay. All right. Simple Sasuke. Okay, you can come up with equation number 1 and equation number 2. All right. So remember that when you talk about this equation number 1 and equation number 2, you have to deal with the vapor pressure of pure A, okay, or at pure B, okay, at certain temperature, at the same temperature. Remember, just now I mentioned XA and YA, they should be in equilibrium. Okay, if they are at equilibrium, meaning that the temperature of liquid A and the temperature of vapor A should be the same. Okay, should be the same. All right. So why do you need to use equation 1 or equation 2? Because sometimes in the given statement, in the given questions, you cannot use directly to find XA from Roth's law, or you cannot find directly YA from Dalton's law because of lack of data given to you. So the other alternative for you to do is to use equation number 1 or equation number 2. Okay, so what is this actually? XA and YA. Okay, look at this. So you have equilibrium curve here. All right. So how do you get equilibrium curve? Okay, each point or each coordinates that you have in this particular curve come from a pair of equilibrium composition of X and Y. So let's say this is at this point, let's say you have XA1, YA1 or something like that. Maybe at this point you have XA2, YA2. Okay, so the subscript 1, 2, 3, 4 until the end of the curve come from different temperature. Okay, so the curve that you have here, okay, the curve that you have here is developed based on different temperature for each mole fraction of vapor and mole fraction of liquid for component A only. Okay, for component A, meaning that the same component A. Okay, so the same component A that you have will give you a different fraction in vapor form or maybe and at liquid form at different temperature. Okay, so based on that, you can develop your equilibrium curve. Okay, now, so this is called equilibrium diagram. Just now you have boiling point diagram. Okay, so we're going to use equilibrium diagram in our calculation. So therefore, you need to have your graph paper with you, in front of you all the time during the tutorial, during the math lecture. Because sometimes I'll give you some example that you need to try again. Okay, sorry about that. Okay. All right, any question regarding to the binary mixture or equilibrium diagram? Please respond. Any question?
No question, Miss.
No question. So far so good, eh? Sekejap ya, nak makan gula-gula, sakit tekak tau. You have question, you ask me, okay? Alright. For equilibrium diagram, you have to make sure that you draw the graph at least 70% of your graph paper. Okay, at least 70% of your graph paper. Okay, and the highest value of mole fraction that you have should be only 1. Okay, the range of the vapor, mole fraction of the vapor should be 0 to 1. Okay, the domain of your graph paper of your mole fraction of the liquid should be between 0 and 1. Okay, and you have to try your best to draw the graph paper at least 70% of the area of your graph paper. Okay.